So in our series of review lessons, this is rounding for both whole numbers and decimals. The process is exactly the same no matter what you're rounding, whether it's a decimal or a whole number. And as a review lesson, this is going to go through a brief motivation for why we might be rounding, a very quick review of the procedures, and then give you a few examples and practice problems that we can look at. So first, we want to talk about why is it that we round at all? What is our motivation when we're rounding? And really, there are two different things we might be rounding for. First, we may not need to know exactly what the full length of a decimal is. We may not need to know exactly what the number is. We just may not need an exact answer for what's going on. If the answer were actually, say, 3,496, it might be good enough just to know that it is right around 3,500. In this case, we're rounding because we don't need to know the exact number. We need an approximate number. Now, most cases when we do any sorts of calculations in the class, we are going to want to have the exact number. But there will be some cases where we don't need an exact number. We just are okay with an estimate. And that is really the second motivation that we have, is we just want to estimate the value of an expression. This could be with adding, subtracting, multiplying, etc. There will be another series of video lessons that are specifically about rounding for the purpose of certain other operations that if you need review on, you can go and look at those. So now let's get into the actual rounding procedures. As you can see, these procedures say rounding decimals, but since decimal is the name of our entire system, we can really say this is just rounding anything, because decimals refer to whole numbers because we talk about decimal numbers. Deci at the beginning meaning 10, and our entire system is based off tens, or the parts of numbers that we're used to calling decimals. So in any case, to round anything to a given place value from any place, you have to look at the digit in the place value to the right, and we're going to see an example of that here in a second. So if we're going to round to the 10th, we're going to look to the hundredth, because that's the place value immediately to the right. If we're going to round to the hundredths, we're going to look to the tens, because that is the next smallest place value, the place value to the right. And then depending on what that place value to the right is, we either round up if the digit is 5 or greater, or we round down if it's from 0 to 4. So let's take a look at a specific example of that with 395.071. So let's pick three place values that we can round to. We're going to round to the hundreds in red. We're going to round to the ones, and we're going to round to the tenths. So if we start with the hundreds, if we are rounding to the hundreds place, we look to the place value to the right. In that case, it's the tens. Now the tens is 5 or greater. So we're going to round up for the hundreds. The tens is going to become a 0. The hundreds is going to round up. So it becomes 4. And then every other place value that is less than that will become a 0. Here, notice that we don't have to add our decimals because all of our decimals are 0. We can if we want to, though. So our answer when we round to the hundreds is 400. Let's take a second to erase these. And now let's look at what we get when we round to the ones. Well, if we round to the ones, we're going to use the digit in the place value immediately to the right, the next smallest. That is the tenths. Now the tenths is a 0. So we're not going to round up because the digit is not 5 or greater. The digit is less than 5, so we're going to round down, which means we leave the number exactly the same, at least in the ones digit. We leave the place we're rounding to exactly the same. So this becomes 395. Again, I'm not going to write the rest of the decimal because we don't need the rest of the decimal. All the decimal places are 0. So we've done that. Let's put this over here. Take a quick erase of those. And now look at what we get when we round to the tens, or the tenths, rather. So if we're rounding to the tenths, we need to look at the hundredths. Now the hundredths is a 7. 7 is 5 or greater. So we round up. 1 up from 0 is 1. That decimal place still exists. The rest becomes 0. And so we have 395.1. There are 395 and 1/10. That is what we get when we round this number to the nearest tenth. Let's take a look at one more example with a few other ideas here. So 0.80635, or 80,635 hundred thousandths, with no whole number there. Let's take a look at rounding to the ones to the thousandths, and to the 10,000ths. So now for the ones, if we're rounding to the ones, we look at the place value to the right. That place value is the tenths. The tenths are greater than 0, so our rounding ends up at 1. No decimal points, we round up, the rest get deleted as part of the rounding. We always delete numbers in a smaller place value, replace them with zeros, when we round using a certain place value. Now let's look at rounding to the thousandths. So we're going to look at the 10,000ths, that is the decimal place to the right, and see 3 is less than 5, so we're going to round down. So the rest of the digits that are bigger, at least in place values, remain the same. The 6 doesn't change because it's rounded down, and then the 3 and the 5 both become zeros. I'll write them here just so we can have them at some point. So 806 thousandths is what we get when we round that to the thousandths. And finally, to the 10,000ths, or rather to the 10,000ths, we look at the 100,000ths. Now 5 is at 5 or greater. A 5 is a round up, so we round that number up to 4, and the rest of the digits remain exactly the same, that are larger. 8,064 10,000ths. That is what we get when we round there. So there are going to be 2 pages of problems for you to work on. In the first page, you're going to round these 3 numbers to the 10th, to the 1000th, and to the ones. Let's make that a different color. To the 10th, to the 1000th, and to the ones. Go ahead, pause the video, and come back when you are ready to move on. So first, let's look at each of these rounded to the 10th. The 10th in the first one is 42.69. The 9 in the 100th is going to be used for that. 9 is greater than 5, so this becomes 42.7. In the second number, the 10th and the 100th are 0. 0 is not greater than 5, so that stays exactly where it is. In this case, it's 153.0. We don't need the 0.0, but let's put it there to show that we are actually rounding to the 10th. And finally, for 0.3952, the 9 greater than 5, so the 3 becomes a 4, and 4/10 is the rounded number. Now to the thousandths, let's go back to the beginning there. 3 is in the thousandths place, so we're going to look at the 4. Or rather in the 10,000ths place for that. 4 is less than 5, so that stays exactly as it is. 42 and 693 thousandths. In the second one, we're going to look at the 9, which is in the thousandths place. Now the 6 rounds the 9 up, but a 9 being rounded up is 10. So while in the thousandths place it is going to become a 10, we can't put a 10 in one place. So it actually becomes 10 as if we were adding, and the 1 goes into the hundredths, so this becomes 153.010. Again, we don't need that 0, but I'm going to leave it there to show that we're looking at the thousandths. And in this case, for 0.3952, 2 is less than 5, so the 5 stays as it is, 0.395. Now finally, to the ones, that means we're looking at the 10th place. 6 causes a round up, so there's 43. 0 causes a round down, so 153. And 3 causes a round down, and when we eliminate all the decimal places, we just end up with 0. So for 3,952 10,000ths, if you round it to the nearest ones, you round to 0. And for the final 3 problems, take a look at these 3 numbers and round them to the hundredths, tens, and thousands place. Go ahead, pause the video, and come back when you're ready to move on. So here, if we're looking at the hundredths place, we use the thousandths, the 3 in this case, indicating a round down, so 297.86. For 8,735 and 927 10,000ths, when we're rounding to the hundredths place, we look at the 7. The 7 indicates a round up, so the 2 is going to get 1 greater to a 3, going to become 8,735 and 93 hundredths. And finally, the 1 indicates a round down, so it's going to remain at 6,082 and 82 hundredths. Now for the tens, going back to the beginning, the tens, not the tenths, the 7 indicates that the 9 should round up. So the 9 rounding up becomes a 10. We put the 0, add the 1 to the hundreds column as if we were adding, and this becomes 300, even though we rounded to the tens. The nearest 10 is 300. In this case, the second number, 8,735.927. The 5 indicates a round up, so this is 8,740. And the 2 in the last number indicates a round down, so 6,080. Notice all the decimal places in all of these get dropped because we're rounding to a whole number, so our decimals aren't at the level that we want. They're too specific. We just want to know what the closest 10 is. And finally, to the thousands. Here, there is no thousands place in the beginning, so the 2 is used to round. The 2 rounds down, and there is no thousands place. So the nearest thousand for 297 point anything is 0. In the second number, 7 indicates a round up, so the nearest thousand is 9,000. And in the third number, 0 indicates a round down, so the nearest thousand is 6,000. One more time, anytime that we round, we're going to follow a few steps. First, we find the place we are rounding to, look at the digit to the place value to the right. If the number is less than 5, round down, which keep in mind, this may round down to 0. But it may not, and if the digit is 5 or greater, round up, keeping in mind that a 9 rounds up to a 10, so you will have to add 1 to the place value column that is 1 greater than that.